Okay, on page 13 we've got to use this grid with lots of lines on it to work out the equations in slope-intercept form of each of these lines. Now, the first one is a very special line because actually it doesn't have a slope. It's a vertical line, which means if you were to, you can't really measure its rise, and also it doesn't have a run. So if the run is 0, we should stop there really. We can't divide by 0. We can't do rise divided by run if the run is 0. So it doesn't have a slope. In fact, this has a very special equation, and you did see these at the start of year 7, but you'll be forgiven for forgetting that. It was quite a while ago. This is the line x equals 3, and it's just got an equation like that because it's got no y in its equation because it doesn't depend on the y coordinate. X is not related to the x coordinate. Sorry, the x coordinate is not related to the y coordinate in this case. It is just 3 at all times, so that's quite a special one, that one. Similarly, graph D, line D, it is horizontal. It doesn't vary, the y coordinate doesn't vary as the x coordinate does. So in other words, the y coordinate will stay at -2 throughout this whole line. So that has an equation y equals -2. Now that's the special ones out of the way. Now we can use the slope-intercept form to work out the equations of the others. So let's go to graph B. It crosses through the y-axis at -3 down there. So I know it's going to be y equals something x minus 3. And that something is the gradient. And to find the gradient, we do the rise divided by the run. So I'm going to find a good place on this line to spot those things. That looks like a good place. So the rise there is 3. It's gone up 3 there, and the run is 1. So 3 divided by 1 is 3. So that's a gradient of 3. Now it's always worth just checking with the numbers on the axes to make sure that 3 squares does indeed mean 3 on the axis. And similarly for the x-axis, going across 1 square is 1 number on the x-axis. But it is in this case. Okay, line C. Let's see where its y-intercept is. It goes through the y-axis at 4. So this is y equals something x plus 4. Positive 4 this time because it goes through at +4 rather than -4. Its gradient, I choose 2 points. That goes through the corners of some squares. It's got a rise of 3 and a run of 3. So 3 divided by 3 would give 1. I could put 1x there, but we don't need to. Because in algebra, we don't often say 1x, we just say x. We've just got one of them. So y equals x plus 4 is fine. Line E. Now this is different, this line, because it's going the other way. It's going downwards, and let's see what difference that makes in a second. But its y coordinate that it goes through, sorry, its y-intercept is 9. So it's going to be y equals something x plus 9. Now its gradient, let's choose 2 nice points. Let's go for there. No, sorry, do that again. It's gone across 1, but this time down 2. So its run was 1, but its rise was -2, we could say. So -2 divided by 1 gives -2 as the gradient. So any line which goes downwards from left to right has a negative gradient. Lines which go upwards when they're going from left to right have a positive gradient. The way I always remember that it's as we go from left to right is because we read left to right. You know, if we're reading a sentence, we're reading left to right. So positive goes upwards, negative lines go downwards. And finally, line F, hopefully you've spotted it's also going to be a negative graph, negative gradient. Let's start with its y-intercept. It goes through the y-axis at -1. So it's going to be y equals something x minus 1. Now let's find its gradient. So I'm going to choose here, going across 2, so a run of 2 and a rise of -1. So rise divided by run, -1 divided by 2 is -8. 1 over 2. Okay, or we could have put negative 0.5. So that's the equation of those lines. On number 4, we've got to draw the lines. So without constructing a table of values, that's the key thing. We've practiced that skill on the page before. We could do that for these ones, but we're going to use slope-intercept form. It's quicker if we can master it. Just zoom out a bit so you can see the whole thing. A bit more. There we go. Right, x equals 3. Now this is one of those special ones where the x-coordinate is just always 3. It doesn't depend on what the y-coordinate is. So if I were to draw a line where the x-coordinate is always 3, well at that point there the x-coordinate is 3. It is at that point, and that point, and that point, and so on. It's going to cause a vertical line. Goes through the x-axis at 3. And because we're going to draw lots of lines on this grid, I'm going to label that as I go. Okay, line B. Oh, I could label it A, I suppose. Let's do that instead. Line B, y equals negative 5. It's a very special one again. Doesn't depend on the x-coordinate. Let's go for a different colour. Y equals negative 5. That just means the y-coordinate is always negative 5. So that's going to be a horizontal line. Here's line B. Okay, C, y equals 2x. So it doesn't have a plus something at the end, but I could put a plus 0, and that wouldn't be changing it at all, and that would tell me that its y-intercept is at 0. It goes through the y-axis at 0. In other words, it goes through there, which we could also call the origin, and it has a gradient of 2, so steepness of 2, which means for every 1 we go to the right, we go up 2. So we're going to go 1 across to the right, up 2, and there is another point on my line. Go across 1, up 2, there's another point on the line. Okay, you only really need a few points before you can start drawing the line in. So it's going to go like that. I'm actually going to continue it in the other direction as well, just because lines should go right to the edge of the grid. Just make sure that goes through the right place. There we go. Okay, and that is line C. D, y equals 2x plus 3. So it's going to go through 3 on the y-axis. So there, and it's got a gradient of 2, so steepness of 2. Again, we're going to go across 1, up 2. There's another point on the line. Cross 1, up 2. And even if we went the other way, we could go left 1, down 2 to give us some other points on the other side. Okay, so let's draw a line through those points. And we can see that line is actually going to be parallel to the line we drew below. It has the same gradient, so it's going to be parallel. Okay, line E, 4x minus 1. Y equals 4x minus 1. So it's got a y-intercept of minus 1, but this time a gradient of 4, so steepness of 4, which means we go across 1, up 4. 1, 2, 3, 4. So there's the next point it's going to go through. Across 1, up 4. 1, 2, 3, 4. Let's go through here. I'm not going to fit another point on up here. Maybe I'll go down the other way. So I'm going to go left 1, down 4. 1, 2, 3, 4. There should be enough points to draw the line. There we go. It's going to get very congested, this grid. Okay. F, 3x, y equals 3x minus 4. So it's going to go through minus 4 on the y-axis. It's got a gradient of 3. So we're going to go across 1, up 3. 1, 2, 3. Across 1, up 3. 1, 2, 3. And just do one more. Cross 1, up 3. 1, 2, 3. There we go. So draw this line in. Oops, that's way off. Try that again. There we go. And that was F. Oops. Line G, y equals a half x minus 9, so it's going to go through minus 9. And this time it has a gradient of a half. Now this is quite tricky. We can go across one and up a half and put another point, but it's quite difficult to see where a half would go exactly on the line. So let me tell you something else we could do. Rather than going across one and up a half and kind of guessing where that is, instead of doing that, let's go across 2 and up 1. So that'll be the same thing, and that will give us a nice corner of a square to plot this on. And we're going to do that again. We're going to go across 2 and up 1. It's just scaling up that information a little bit more. Instead of across 1 and up a half, we just double that and we go across 2 and up 1. There we go. It's much easier to draw. That's line G. Okay, H says y equals negative x plus 6. So this is the first one we've had that's got a negative in front of the x. But I'm going to start here again. So it's got a y-intercept of positive 6. It's going to go through here. Now it's going to go across 1. We always go left to right, but it's going to go down 1. So cross to the right, down by 1. So that's here. Cross to the right, down by 1, and so on. Okay, so I've already got enough information there, I think, to draw this line in. It's going to keep going like that. And that is line H. Line I, y equals negative 2x. Well, we've drawn the line y equals 2x, and that went through 0. Well, this one is also going to go through 0. Because there is no y-intercept here. So it's going to start at the origin again, but it is going to have a gradient of negative 2, so we're going to go across 1, down 2 this time. Across 1, down 2, across 1, down 2, and there we've got a few points. Should be enough. There we go. And finally, J, y equals negative 3x minus 2. It's going to go through minus 2. Very congested now. And it's got a gradient of negative 3. So we're going to go across 1, down 3. So it's going to go through here. And we're going to go across 1, down 3. So share this point. And we can't fit another one on that way, but maybe we can go back the other way and go left 1, up 3. So I'm going to go through here as well. Left 1, up 3. So that's where I'm going to start. There we go. And that's line J. All done.